Okay, good morning. This is the video over 10.1 confidence intervals between the difference in proportions. As always, you should start by reading the book. I would like you to read right now a really short book. I'm going to try to keep these short with the videos, 625 through 629. Read that book. It talks about confidence intervals. Hit pause while you do that. And then after you've read that book, unpause it and we'll get back to what we need to talk about. Okay, now that you've read, this is a two-sample Z interval for the difference of proportions, and it has kind of a big formula, one of the bigger formulas that you'll see in math. But if you notice, it really takes the same shape as some of the other confidence intervals formulas. It takes the shape of statistic plus or minus the critical value times the standard deviation. The reason it gets so big is because our statistic is the difference of proportions. Z star, we've seen that situation before. Plus or minus, I forgot the minus. Z star, and it is a proportion, so we do have Z situations here. We're going to have to check for Z conditions, do all of those things. And then our standard deviation also takes a similar form from what we've had, and that is this within that, we've seen a formula that looks like that. You take P1 hat, 1 minus P1 hat over N, and then you add to it the same thing with the second proportion. And what this will give us, it will give us a confidence interval, which is a set of plausible values that we think is going to appear if we were to do this simulation, this experiment, whatever. If we were able to do it many, many, many times, what 95% of the time we would capture the true proportion. What we're going to do, it almost makes a lot of sense when you do it in an example format. We'll be able to talk about conditions. We're going to do alternative examples, approval of the president. And by the way, this is about approval ratings for Trump, and totally not trying to get political or anything. I'm not a huge political guy, so not trying to say Trump is great or Trump is bad or anything in between. All I'm doing is the math required for the problem. So let me get you to that, and we'll go from there. Okay, here's the problem. Gallup regularly conducts polls asking U.S. adults if they approve of the job the president is doing. How did Trump's approval rating change from his first day in office to his 100th day in office? According to a Gallup poll of 1,500 randomly selected U.S. adults taken on his first day of office, 45% approved of Trump's job performance. Another Gallup poll of 1,500 U.S. adults was taken on the 100th day and showed a 38% approval rating. So what we're asking is there evidence that his approval rating dropped, which honestly most presidents' approval ratings do drop from day 1 to day 100. Did it drop? Well, there's preliminary evidence that it did drop. From 45 to 38 tells me, yeah, there's evidence here. But is there convincing evidence? Is there enough evidence to say that, hey, these numbers could have happened simply by sampling variability, or because my sample size is big, would I expect there not to be that big of gap in those two numbers? And that's really what this confidence interval is going to do. And when we're done with the confidence interval, there's some things about it that will tell us if we're on the right track or not. So first of all, we're going to state, and we know, and you can do this just right along with me in your notes. You've taken these home. We're good. And we definitely want a 95% confidence interval, CI, for the difference in proportions for P1. And we're going to say the first day minus P100, where P1 is equal to Trump's approval rating on day 1, and P2 is equal to Trump's approval rating on day 100. And we're going to develop a confidence interval for this. So what I would like you to do is I would like you to plan what kind of situation this is and check conditions now. Press pause and go ahead and do that. Okay, back at it. This right now, because we have two proportions and we've tested twice, we see 1,500 randomly selected once and 1,500 randomly selected again. We do have a 2-sample Z interval is what we're going to be performing. Random. Now you do have to check these conditions for both. It's not, you can't just do it one. So P1 random SRS and P2 random SRS, those both check out. For us, the 10% condition, well, again, we're going to have to check it for both. The nice part about this one is for P1 and P2, the number is 1,500. So I would assume that 1,500 is less than 10% of all U.S. adults. And the last one is the large counts CLT condition. And it's not CLT on this one because it's not means. It is a large counts condition, so we would have to check it for both. And I put P1 and P2. I should be putting P1 and P100. I'll put P1 and P100. So for P1 and P100, I will check that large counts condition, which you take 1,500, your sample size, 1,500, and you check that times the proportion, which one of them was 0.45, and then you take 1,500 times 1 minus 0.45, and then you take 1,500 times the 0.38, and then you take 1,500 times 1 minus the 0.38. And what we're really checking on these, and I can look at these numbers and I can tell they're all okay. We're trying to see if they're greater than or equal to 10. Okay, and they are. So we have our problem stated. We have our conditions met. The next thing will be to find our confidence interval. And what we're really doing here is we're going to find a confidence interval for P100 minus P1. And before I get started, here's what I would expect. If we're right, if our idea is that, well, his approval rating on day 100 is going to be less than his approval rating on day 1, well, what should happen with this? Well, this should be smaller than this. So I'm assuming that when I'm subtracting those two numbers, that this confidence interval is going to be negative. And that's really important when we're analyzing this thing, is when I analyze that confidence interval, is it positive, is it negative, does 0 appear in that confidence interval? And those are the types of things that we're going to do. So we're going to write the confidence interval formula. What I would encourage, we'll write it out here. We're going to take P100 minus P1, and those are our statistics. And we're going to put plus or minus. I'm going to encapsulate it like that. Plus or minus the Z star value. And now I have that big long square root thing. And I'm going to take P100, 1 minus P100, and that's the proportion on the 100th day that we found. And I could really put the hat over there because it's not his actual, we didn't survey the whole entire United States, every person. This is the estimated, this is the statistic, not the parameter, all over the n value plus, and then his first day, P1, 1 minus P1 over n. And what I would like you to do is I would like you to hit pause right now, make sure you do it, and go ahead and find that confidence interval. Okay, back at it. You should have put 0.38 minus 0.45 plus or minus. Now my Z star value is that critical Z value that we've been dealing with. 1.96 square root of, well, my P100 value is 0.38, 1 minus 0.38 all over the 1,500 plus my P1, which was 0.45 times 1 minus 0.45 all over the 1,500. And we run through that math. We make sure we have our order of operations correct. And what I got is I got -1, a confidence interval, -0.10 52. And then the other one I got is negative 0.0348. Negative 0.0348. And the fact they're both negative is significant. So I'm going to conclude. I am 95% confident the true difference in proportions I'll write it. So I wanted P100 minus P1. The true difference in proportions is contained in the interval from negative 0.1052 to, I guess I don't need that, to negative 0.0348. So we have a confidence interval, and we've done all the math, but really want to focus right now. The last thing here is there's another question right here. So hopefully you have this, and I'm gonna cursor up here. It says, and maybe I'll bring it all the way up here. It says, based on the confidence interval in Part A, what conclusion would you make about whether Trump's approval rating has changed, and justify your answer? So I'm just going to talk about this. You guys can fill in this on your own sheet. But the fact that the confidence interval, we're 95% confident that his approval rating from the difference in approval rating, it occurs in one of those. Well, they're both negative. So do we think that Trump's approval rating has gone up or down? Well, I would definitely say that according to these numbers, Trump's approval rating has gone down because there's no positive values in there, and there's not zero, specifically zero. Because if zero was contained within that confidence interval, P100 minus P1, if zero was a plausible value, or if any positive number was a plausible value, what we would say with that is, well, there's a chance by sampling that maybe his job performance, maybe his rating hasn't changed at all. But because they're both negative, we're going to say, okay, hey, zero or positive numbers aren't contained within that confidence interval, so we're 95% confident that his approval rating has gone down from day 1 to day 100.